This lecture covers Unit 3 of EMS 189. This is the first part. This lecture is taken from Chapter 3 of your AAOS Anatomy and Physiology textbook. Our objectives for this unit are to describe the function of the skeleton, explain how bones are classified and give an example of each, describe how the embryonic skeleton is replaced by bone, and state the nutrients necessary for bone growth. We're also going to name the hormones involved in bone growth and maintenance and explain what is meant by exercise for bones and explain its importance. We're going to identify the two major subdivisions of the skeleton and list the bones in each area. We're also going to talk about joints and give an example of each type of joint and the movement that's allowed by each type. Let's start off by talking about cartilage, tendons, and ligaments. These are important tissues. They're classified as connective tissues. They work with bones to provide the support framework for the skeleton. Essentially, they're hooking the bones together and attaching the bones to muscle so that the muscles can move bones and provide movement for the body. Cartilage is defined as plates of shiny connective tissue that are surrounded by the perichondrium and lubricated by synovial fluid to provide a slippery surface over which bones may move freely. What is synovial fluid? It's a clear, transparent fluid. It's very thick and viscous. It's secreted by the synovial membrane. Not all joints are synovial joints, but most are, namely your elbows and your knees. This is where it comes in to play most often. The sac that holds the synovial fluid around the joints is called the bursa sac. There are baroreceptors within the bursa sac, which give signals to the central nervous system and determines how much fluid is manufactured and supplied to the bursa sac. If the pressure is too low in the sac, the body will continue to provide fluid to that sac until the pressure becomes adequate. So if that sac in any way is torn or broken such that the fluid leaks out, your body will continue to pour fluid there. It causes pain and inflammation and swelling. This condition is commonly known as bursitis. The perichondrium is a double-layered connective tissue membrane that surrounds the cartilage. It's the outside membrane or covering for your cartilage. Tendons are specialized tough cords or bands. They're very dense, coarser connective tissue. They connect muscles to bones. They're continuous with the periosteum of the bone. The periosteum is the double-layered membrane that covers the bones, except where there's an articular surface, meaning except for where two bones are connected together at a joint. So the periosteum is to the bone what the perichondrium is to the cartilage. The tendons are composed of densely packed fibers of collagen. Collagen is a twisted rope-like protein. Collagen is very important in giving flexibility and strength to your bones and tendons and your skin, as a matter of fact. So without collagen, the skin becomes thin and almost transparent in appearance, and the bones become brittle and likely to fracture or sustain injury. Also, the tendons become weak as well as ligaments. So people with low collagen have a tendency or a predisposition to bone and joint injuries. You can think of collagen like reinforcement bar in concrete. The steel bars are put into concrete to allow the concrete or masonry products to be able to take tension. Without them, concrete can take a lot of compression, but is incapable of taking any type of tensile stress. Collagen provides the same type of stability for bones, tendons, ligaments, and skin. The ligaments are tough white bands of tissue that bind bones together. They're composed of collagen. They're often less compact than those in tendons. Ligaments are more flattened than tendons, forming sheets or bands of tissue. A joint is defined as a point where two or more bones come together. Movement occurs when a muscle contraction causes a tendon to pull on the bone, resulting in motion at a joint. But all motion is not the same at every joint, and all joints are not the same. We'll explore here in a minute the different classifications of joints and the types of motion that are allowed for that type of joint. A sprain is caused by the stretching or tearing of a supporting ligament due to the partial or temporary dislocation of the bone. A strain occurs when a muscle is stretched or torn, resulting in pain, swelling, and bruising of the surrounding soft tissues. Oftentimes we use the term sprain and strain interchangeably, but they really describe two distinctly different injuries. Sprains and strains are generally graded based on their severity and physical findings during examination. There is a grading system for sprains and strains. It goes 1 through 5, and it's listed in your textbook. Bones are a specialized form of connective tissue. They protect the internal organs. Of course, they enable movement and storage site for minerals, particularly calcium, and they have a role in the formation of blood cells and platelets. Your red blood cells are made in your bone marrow of some of your bones. That process is called erythropoiesis. We'll discuss that later in the unit dealing on the cardiovascular system. Bones consist of collagen and the mineral hydroxyapatite. Hydroxyapatite is a compound that contains calcium and phosphate. Without this mineral, the bone is very flexible. Collagen fibers act like reinforcing rods in concrete, as I mentioned before, which also lend flexible strength. Bones are formed from hyaline cartilage during fetal development and later converted into bone. They're constantly remodeled during life to adjust to various stresses. So a lot of times we think that our bone is stagnant or never changes, but actually our bones are constantly added to and changed by our body. Uh, One way that you can show this to yourself is look at a picture of your face from 5 or 10 years ago, and then examine the way your face looks now, and you'll see that the shape of your face has changed over time. Normal growth of bones is controlled by growth hormones working with the thyroid hormones. Calcitonin and parathormone hormones are two that are the most important in regulating bone remodeling and regulating blood calcium levels. When we talk later about electrolyte levels and imbalances in the human body, calcium, you'll notice, rarely comes up. And the reason for that is that the body has the ability to either take calcium from bone tissue and put it back into circulation, or to take excess calcium in circulation and deposit it on bones with the proper hormonal control. Uh, your bone health is dependent in large degree upon calcium-rich foods, vitamin D, and exercise. Vitamin D helps the body absorb calcium. Any type of weight-bearing activities help slow bone deterioration or thinning. When weight is applied to bone on a regular basis, the bone becomes more dense and the mass of the bone increases. This is why movement and exercise is very important for bone health. One example of where this can come into play is when astronauts spend an extended period of time in a low gravity or no gravity atmosphere. When they return to the normal gravity of Earth, they oftentimes have atrophied bones, meaning their bones have become very small compared to what they were before they left on the trip. There are several different types of bone cells. There's osteoblasts that helps produce the bone tissue, the osteocyte, which is the bone cell itself. This is an osteoblast that becomes surrounded by the bony matrix. The osteoclasts are large multinucleated cells that dissolve bone tissue.